bisector theorem, and I've already written it in both directions. Know that the original statement is just what's in pink. So it says that a point lies on the perpendicular bisector of a segment if and only if the point is equidistant. I did not finish writing it. Equidistant from the endpoints of the segment. And I'm going to prove it in this direction first. It says that if a point lies on the perpendicular bisector of a segment, then the point is equidistant from the endpoints. So what I want to prove is I want to prove that the distance from A to P is the same length as it is from B to P. I want to prove that these two lengths are congruent. So I start off with what's given, and what's given is that P lies on perpendicular bisector of AB, of segment AB. Okay, that's what's given. 2, now I'm going to have certain things based upon that. So I'm going to call this point where they intersect M, and I'm going to say that AM is congruent to BM. And I'm going to say that, let's say 1, 2. Let's say angle 1 and angle 2. I'm going to say angle 1 is congruent to angle 2. And why is that true? That's true because these are both 90-degree angles. You could say all, or right angles are all congruent or whatever, but we know that these are right angles because I don't know, L, whatever line, this is the perpendicular bisector, is gonna make it so these two angles are equal, right? It's gonna make it so this is 90 and this is 90. So we could say definition of perpendicular bisector. And we also know, right, that AM, right, is congruent to BM because it must bisect segment AB. So that means that this AM must be congruent to BM. And again, by definition of perpendicular bisector. 3. I'm going to say the seemingly redundant thing, which is that PM is going to be congruent to itself. Then you could say reflexive. Now, the next thing that I'm going to say is that triangle PMA is congruent to triangle PMB. And why is that? Well, they share side PM. That's what we just showed. They have angle 1 and angle 2 congruent. And then we have BM congruent to AM. And that's side, angle, side. So I have these two triangles are congruent. So triangle PMA is congruent to triangle PMB. And again, that's because of side, angle, side. They share side PM. Angle 1 is congruent to angle 2. That's the angle. And then side AM is congruent to side BM. 5. PB is congruent to PA. Why is that true? The two triangles are congruent, so all the corresponding parts must be congruent. So PB is congruent to PA. And I'm done. That's corresponding parts of a congruent triangle are congruent. CPCTC. And I'm done with one direction. I've shown that if a point lies on the perpendicular bisector, then it must be equidistant from the endpoints. Now, this one here, 1, right? What am I given in this case? I'm given that P is an equal distance as it is from A as it is from B. So I'm given the fact that P is equidistant from the endpoints, one way to say that is that PA is congruent to PB. And that's given 2. Now, after we have that PA is congruent to PB, we need to state that PM is perpendicular to AB. Okay? We know that this must exist, some segment PM, and we're going to say through P there must exist some segment that's perpendicular to AB. Call that PM. So PM is perpendicular to AB. Okay, and we should say that for every point off of a line, there exists a segment that's perpendicular to the line. Okay, so there exists a segment through the point perpendicular to the line or to the segment. So for every point off a segment, there exists a segment through the point perpendicular to the segment. Okay, and we're calling that segment PM. Now, you might think that we're done at this point, but we have to be careful, right? What's the other thing? So I have it that PM is perpendicular, but I need to still show that AM is congruent to BM. That this segment, this line, PM, or this segment PM, bisects AB, right? So the way it is that I do that is that I say, well, I know that this is congruent to itself, so I could say PM is congruent to itself. The segment is always congruent to itself. That's reflexive. And then after that, after you have reflexive, you should see that this is side-side angle. And side-side angle only works when the angle is a 90-degree angle, which is this case. So you have that these two triangles are now congruent. So I have triangle PMA is congruent to triangle PMB. And this is either, you could say hypotenuse leg, that's what it's called, or you could say side-side angle or angle side-side, same thing, angle side-side angle, and it's a right triangle and right triangle. So it only works, side-side angle only works when it's a right triangle, and it's called hypotenuse leg theorem. Okay, 5. Last thing, after it is that I've shown that, I know that AM must be congruent to BM because corresponding parts in a congruent triangle are congruent. So I have AM is congruent to BM. And that's CPCTC. And I'm done with both of these proofs. And again, this is one proof. This is an if and only if I prove it in both directions.